All right, the last problem that we're going to look at using the Excel spreadsheet for solving the heat diffusion equation using the finite difference technique is going to be a problem that involves radiative heat transfer. And what we're going to work on here is we're going to work on a problem involving a bar of copper that is 10 millimeters by 10 millimeters, and it is sitting on an insulated surface, and so there is insulation on the bottom of the bar, and then the 10 millimeter by 10 millimeter bar will be there's internal generation in the bar at a rate of 5 times 10 to the 5 watts per meter cubed. The copper bar thermal conductivity is 401, and there is radiative and convective heat transfer from the 3 upper exposed surfaces of this square bar. The environmental conditions that this bar is sitting in, the free stream ambient temperature 25 degrees C, as is the surroundings, and so converting that to Kelvin, that's 298 Kelvin. Convective heat transfer coefficient, we have a mix between forced and natural, about 20 watts per square meter Kelvin. Emissivity, we'll assume this copper bar has an emissivity of 0.75, so maybe it's a little tarnished. And the grid spacing that we're going to use is 1 millimeter for both delta X and delta Y. And with that, the 10 millimeter by 10 millimeter bar, so in the horizontal direction, 10 millimeters divided by the 1 millimeter grid spacing gives us 10 cells plus 1, so 11 cells in the horizontal. And for the vertical, again, 10 millimeters divided by the 1 millimeter grid spacing plus 1 gives us 11 cells in the vertical direction. So let's go ahead and set that up, and then we'll see how it operates when we use Excel. So I'm going to begin by clicking in a cell in a corner here, and I'm going to color it just like we've done with all the others. And we said that there were 11 in the horizontal. So there we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll color code those, and you know what I'm going to do? Let me set the width of all of them to the same. So we'll do something like that. There we go. And then 11 in the vertical. And I will color code that. And then we fill it in here. And again, enter in the values. Starting initial condition for our grid, just like we did with the other examples. All right, and if you want to put your boundary conditions on here, I'm just going to put the lower one. That was an insulated boundary, so we'll make that a gray. Now let's do pink. Pink for fiberglass pink. Okay, so there we have our bar. It doesn't look square, but it is, because we're going to set delta X and delta Y equal to 1 millimeter. And let's go in and start entering in the values. We said that the internal generation was 5 times 10 to the 5, so 5E05. K was 401. And delta X and delta Y was 1 millimeter, so 0.001. Now, one thing that we should do, let's go under options here. And depending on the version of Excel that you're using, if you go under formulas, sometimes it's under calculations. There's so many different versions of Excel. But enable iterative calculation, you want to have that checked. And here you can specify the number of iterations. I'm going to specify it to be 5,000, or the maximum change to be 0.00001. So that's a very, very small change. You can play with this, and that will set, when you push F9, it will either get to 5,000 iterations or this being the maximum change. So we'll set that for this particular calculation. Other boundary conditions we have, let's go find the insulated and then the radiative and convective. So scrolling down, that's a convective boundary. Insulated, there we go. Okay, so we need to set 401, delta X 0.00, what did I say, 1 millimeter, so that is 0.001, and Q dot was 5E05. Okay, so we've done the insulated boundary. Now we have to find the radiative heat transfer with convection, constant heat flux, composite solids, another composite solid, Radiation and convection. Okay, this is the one that we want. Emissivity we said was 0.75. So we enter that. Surrounding temperature, be careful here. I mix units. I have degrees Celsius and Kelvin, so this one is 298 K. Stefan Boltzmann constant. Oh boy, I deleted that. Let me pull it from down below. It's right here. I deleted that earlier. That should be in your spreadsheet. There we go. H was the convective heat transfer coefficient, 20 watts per meter squared Kelvin. Thermal conductivity, we said copper, pure copper, 401.001 for the delta X, delta Y, 1 millimeter. And Q dot was 5 to the 0.5. And T convection, now this is in degrees C, it was 25 degrees C. Now, one thing when you're dealing with the Excel spreadsheet and radiation, you'll notice these are still showing divide by 0. And what we need to do is find the boundary conditions that we're going to use. So we're going to use this one because if I go to our object, that would be the boundaries over here. So we're certainly using a right boundary with convection and radiation. So I'll scroll back down to that. Okay, here we are. So what you need to do, once you've entered these values, you need to go into the cell, go up into the formula bar, click there and push enter. And then it converts it to a number. If you try copying and pasting this into your spreadsheet, into your grid, it's going to mess it up. I don't know why Excel does that. Don't ask me. That's just the way that it works. And probably some of you out there know why. Send me an email if you know why. And I'll fix it in the spreadsheet. And now top boundary condition. There we go. Bottom, we don't have a bottom. We do have an upper right-hand corner, so I'm going to click there, go up into the formula bar, hit enter. We do have an upper left, so I'll click there, up in the formula bar. And the right, we don't have a lower right, we don't have a lower left, so I think I've done all of the ones that we need. So what I'm now going to do, I'm going to copy and paste in the boundary conditions into our grid, and we'll begin with the insulated boundary. And so what I will do, we had a lower surface, so these are the middle ones. So I'll copy going up to our grid. There we go. So I'm going to paste into those. And then what I'm going to do for the corners, let's go back to the insulated boundary. Insulation, I'm going to pick this corner and this corner. So this will be the lower, the bottom right. So I copy. I apologize for the bell, but that's the quickest way for me to get around Excel. Then the other one down here, I'll copy, and then I'm going to paste into that one. And if you want to see what cells are being used, just like I said before, go up in the formula bar and you can see that it's using those cells there. These ones in the middle, they're just using the ones around there. Okay, so now what we need to do, we need to handle the radiative boundaries. I'm going to begin with the corners. So let's start with the upper left, and we'll scroll all the way down to where we had the radiation. Where was radiation? Oops, I'm gone too far down. Radiation is here, so let's get the upper left. So I'm going to click there, Control C. I'll go up. So that's the upper left that we're dealing with. And it's going to complain here. And the reason is because it's scientific. So change that to number. Everything is good. And then the other one, let's get the upper right. Where's upper right? There it is. Okay. Going back up to our grid. There we go. Again, it's playing the game by the fact that it's giving us a scientific. I guess I must have set that cell scientific when I set up the Excel spreadsheet. Anyways, you can change it. Now what we need to do the left, the right, and the upper. So let's go get those cells. Let's start with the left. Finding our radiative condition with convection. There's the left. Click there. Control C, go back up. And then there, this is kind of like playing Minecraft. Okay, let's see. I don't play Minecraft. I watch people play Minecraft and I'm puzzled by it. But anyways, okay, the right surface, Control C. Okay, and I apologize if you're a gamer and you feel offended by that comment. I used to spend a lot of time playing video games when I was young. I guess I got it out of my system. Okay, there we go. That's the last one. Radiation and convective boundary, upper. We click there, Control C, going back up. And now what I'm going to do is I'm going to copy and paste, Control V. And if you're wondering again, are those cells correct? Are they pulling in the right conditions? Yeah, that looks good. Clicking there, yeah, it's pulling in from the inside. That one looks good. These ones here, yeah, they're pulling in from there. That's pulling from the inside. Everything looks good. So the last thing that we need to do here, let's check the corners. I think I've already done these, but I'll do them again. Corners look good. Okay, the last thing we need to do, we need to copy the interior node. So we've done the boundary conditions. The interior node was with generation. We have it right here. So I do Control C, I do Control V, paste it in. There we go. Let Excel run. And what you're noticing down in the bottom here, you see the number of iterations. It's kind of slow, and the reason is because we're watching it. If you scroll down and don't watch it, and we'll do that in the next run, you'll notice that it moves much, much quicker. So we'll let this one do its thing. It's trying to converge. And so what it's doing is it's going through calculation after calculation, applying the finite difference technique. An iterative convergence process is what we're essentially doing here. So I'm going to hide it. I'm going to push F9. Now watch down here, the number of iterations, much, much quicker. So that's the way to move the simulation a lot quicker than watching the numbers. And it's just because it takes time to generate those numbers and display them. And if you're not displaying them, the computer is much quicker. And so what we do, we keep pushing this. Let's take a peek. Oh, look at that. We're already at 67 degrees. So it's getting warmer. That's good. I know what the answer is, but I know where we should be going. Average, oh, that's kind of neat. It's showing us the average there. So we know what the temperature is, average in our grid. So we can see it's still changing. And you'll notice that it's starting to converge when you push F9 and it no longer does the iterations. So we're still going. And now you can see it's changing very little each time I push F9. So we've exceeded the thresholds that we set. So that means that we're pretty close to having a converged solution. Let's go take a peek. There we go. That's what it looks like. So this is a copper bar, 10 millimeters by 10 millimeters with internal generation, radiative heat transfer around the perimeter, insulated bottom. So let's select it. Coming up, insert, we're going to do a contour plot. There we go. Let's position the contour plot down below. The color, yeah, that's probably as good as we're going to get. We can try other colors if we want. Yeah, that one's not bad. We can see the difference. Now, the thing about Excel, I talked about this earlier with the contour plot. It does funny things. So go under Layout, Axis, Depth Axis, and Show Reverse. And that is what we're looking at. That's the actual result of our simulation. So that is an example of using the Excel spreadsheet for solving a problem with radiative heat transfer. The most important thing to remember when you enter the radiation value, go into the cell and click and enter up in the formula bar. If you recall what that was, where were we? Right here. So for example, if we wanted to use this bottom, you'd have to go into this cell here, go up into the formula bar, click enter, and it populates it. If you try copying and pasting this into your spreadsheet, it's going to mess you up and it won't work. So that is the Excel spreadsheet, and that is the finite difference method. It's kind of a neat little tool for quick and dirty calculations. Not always the most convenient, but it works and it's quick. So that gives you an introduction to finite difference and heat transfer calculations.